Welcome to Beyond the Brackets. Today we are going to explore an important concept in mathematics, infinite series. If un is a sequence of real numbers, then this expression is called an infinite series and is denoted by summation n is from 1 to infinity un or simply summation un. If all the terms of the series are positive, then it is called a series of positive terms. For example, consider this series as all the terms in this series are positive, so this is called a positive term series. An important point to remember, for a series to converge, its terms must approach 0 as n tends to infinity. That is, limit as n tends to infinity, un will be equal to 0. But this condition alone is not sufficient to guarantee convergence. So we need proper tests to determine whether a series converges or diverges. One such test is D'Alembert's ratio test, also known as ratio test. If summation un is a series of positive terms such that limit as n tends to infinity un by un plus 1 is equal to L, then L greater than 1 implies the series converges, L less than 1 implies the series diverges, and L is equal to 1 implies the test fails. You might wonder, when should we actually use the ratio test? It's useful when the terms of the series involves factorials or exponentials or both, as given in the examples. The reason is that when we take the ratio of the consecutive terms, these expressions simplify very nicely. The question says determine which of the following series converges. In the first question, observe that 2 power n is the term that is raised to n. Such terms simplify well when we take the ratio test. Let's start the solution by denoting the general term by un, which is n power 4 by 2 power n. Then un plus 1 is obtained by replacing n with n plus 1. So un plus 1 will be equal to n plus 1 power 4 by 2 power n plus 1. To proceed with the ratio test, we first consider the ratio of un and un plus 1. Here un is n power 4 by 2 power n. When dividing by a fraction, we multiply its reciprocal, that is 2 power n plus 1 by n plus 1 power 4. 2 power n plus 1 in the numerator can be written as 2 power n into 2. So 2 power n in the numerator and in the denominator cancel out, leaving n power 4 into 2 by n plus 1 power 4. We factor out n power 4 in the denominator so that n power 4 in the numerator and in the denominator cancel out, and we are left with 2 divided by 1 plus 1 by n power 4, which helps in evaluating the limit. Taking limit as n tends to infinity, 1 by n will tend to 0. So the expression becomes 2 divided by 1 plus 0 power 4, which is 2. The limit obtained here is 2, which is greater than 1. So by ratio test, the given series is convergent. In this question, observe that we have 2 power n divided by n factorial, which simplifies well when ratio test is taken. Denoting the general term by un, that will be un is equal to 2 power n by n factorial. Un plus 1 is obtained by replacing n with n plus 1. So we get un plus 1 is equal to 2 power n plus 1 divided by n plus 1 factorial. To apply ratio test, we take the ratio of un and un plus 1. So un is 2 power n by n factorial. Since we are dividing by un plus 1, so its reciprocal is taken in multiplication. So we get n plus 1 factorial divided by 2 power n plus 1. Here 2 power n in the numerator is as it is. In the denominator, 2 power n plus 1 can be written as 2 power n into 2. N plus 1 factorial in the numerator can be written as n plus 1 into n factorial. The terms 2 power n and n factorial cancel out in the numerator and in the denominator. We are left with n plus 1 by 2. Taking limit as n tends to infinity, n plus 1 by 2 tends to infinity. Since the limit here is infinity, which is greater than 1, by ratio test, the given series is convergent. Moving on with the next problem. Here un is 3 power n plus 1 by n plus 1 into 2 power n. Un plus 1 will be obtained by replacing n with n plus 1. So we get un plus 1 as 3 power n plus 2 divided by n plus 2 into 2 power n plus 1. To apply ratio test, take the ratio of un and un plus 1. So un is 3 power n plus 1 by n plus 1 into 2 power n. Since un plus 1 is in the denominator, We multiply its reciprocal to get n plus 2 into 2 power n plus 1 by 3 power n plus 2. Here 3 power n plus 1 in the numerator can be written as 3 power n into 3. 3 power n plus 2 in the denominator can be written as 3 power n into 3 square, that is 9. 2 power n plus 1 in the numerator can be written as 2 power n into 2 divided by 2 power n. We are left with the terms n plus 2 in the numerator and n plus 1 in the denominator. Here 3 power n in the numerator and in the denominator cancel out. 3 in the numerator and 9 in the denominator cancel out, and we are left with 1 by 3. 2 power n in the numerator and in the denominator cancel out, and we are left with 2 in the numerator. Factor out n in the numerator, we get n into 1 plus 2 by n, and in the denominator factoring n, we get n into 1 plus 1 by n, where n in the numerator and in the denominator will cancel out. We are left with 2 by 3 into 1 plus 2 by n by 1 plus 1 by n. Taking limit as n tends to infinity, 2 by n tends to 0 and 1 by n tends to 0. So we are left with 2 by 3 into 1 plus 0 by 1 plus 0, which is 2 by 3. Since 2 by 3 will be 0.6, which will be less than 1, so by ratio test, the given series is divergent.